Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about square roots. Okay, well, when we talk about square roots, what are we really talking about? What do we mean? Okay, let's talk about some definitions. A square root of a number, it's going to be s, is a number x whose square is s. Well, that all sounds very confusing. Let me restate that. So a square root of a number s is a number x whose square is s. So in other words, I can rewrite what I just said as x squared is equal to s. So the square root of s is going to end up being plus or minus x. And if I give an example, I could say that x squared is equal to 25. And in that case, if I say x squared is equal to 25, let's use blue because I got a lot of black on this page, x squared is equal to 25, then I know that x, which is going to be negative 5 or plus 5 squared, is going to be equal to 25. All right, a positive number has two square roots. Right, so my positive number 25 has two square roots. If I try to, if I take the square root of 25, it's going to be plus or minus the square root of 25. It'll be plus or minus the square root of 25. So my example, minus 5 squared is equal to 25, and 5 squared is equal to 25. So a positive number has two square roots. And remember that negative in parentheses 5 squared is equal to 5 squared, and then we apply the negative sign. So remember PEMDAS as you take care of these three different possibilities. Negative in parentheses 5 squared is equal to negative 25. First we square the 5 value exponents first, and then we apply the negative or multiply by negative 1. Then there's negative 5 squared. That is also equal to negative 25. And again, what we're doing is we're handling the exponent first, and then we're applying the negative sign. So it'd be like negative 1 times 5 squared. And then finally, I have negative 5 squared, and that in parentheses is equal to 25. So just be careful when you're presented with these different possibilities what the results are going to be. All right, the principal square root is the positive square root of a number. So back to our example where we had x squared is equal to 5. The principal square root of 25 would be equal to 5. So it's the positive square root of that number. Now let's talk about radical signs and different definitions. So a radical is an expression written as a square root of some value. So it includes the radical sign and what we call the radicand together. So the radical sign is just the radical sign. It's written as you see here. The radical sign is just listed as to the left of the arrow. And the number under the radical sign is the radicand. So the radicand and the radical sign make up the radical as an expression. Right, properties of square roots. When we talk about properties of square roots, we have a product property and a quotient property. In both cases, a must be greater than 0 and b must be greater than 0. So the product property states that the square root of a times b is equal to the square root of a times the square root of b. And this will help us when we talk about simplifying a square root. And the example that I give you, I have the square root of 18. So if I use the product property, I can say the square root of 18 is equal to the square root of 9 times the square root of 2. And I know the square root of 9 is 3, so I end up with 3 root 2 as my answer. Now the quotient property is similar to the product property, where we take the square root of some value and separate it into two values with square roots, so two radicals. And in the quotient property, the square root of a over b is the same as the square root of a divided by the square root of b. In the example here, I have the square root of 25 over 4, and I can rewrite that as the square root of 25 over the square root of 4. And that ends up being 5 over 2, or 2.5. So again, if x is greater than 0, then r squared equals x has two solutions. R is equal to plus the square root of x, and r is equal to the negative square root of x. Okay, rationalizing the denominator. Now, as part of math speak, we say that we need to rationalize the denominator. And in this case, it means that we don't want to have any radicals left in the denominator as our solved expression or equation. So I say the math gods have determined that there shall be no radicals in the denominator. And really, it is really the math way of writing things that has dictated why there should not be any radicals in the denominator. So that's the process that we're going to follow. Now, how do you rationalize the denominator? In this case, how do you remove the radical from the denominator? Well, there are really two cases. One in which the denominator is a radical only, and one is the case in which there's a radical plus some constant. So if the denominator is a radical only, then we're simply going to multiply the numerator and denominator by the denominator as a radical. So remember, if I have 3 over root 5 and I multiply it by root 5 over 5, I'm just rewriting the equation. I call it just hairbrushing, because I'm multiplying 3 over root 5 just simply by 1. Okay, so I've done nothing to change the value of the expression. The only thing I've done is change the way that it's represented. So I multiply 3 times root 5 and root 5 times root 5, and I end up with 3 root 5 over 5. So you can see that by multiplying the numerator and denominator by the denominator itself, which is root 5, I end up removing the radical in the denominator. It becomes 3 root 5 over 5. Now the second case is where I have a radical plus a constant. In that case, I'm going to multiply the numerator and the denominator by the conjugate of the denominator. Well, what is a conjugate? It's just simply a modification of the expression in which the operation, either plus or minus, is changed from plus or minus to plus, or minus to plus. It's either changed from plus to minus, or it's changed from minus to plus. So the conjugate allows us to rationalize the denominator, or to remove the radical sign in the denominator. And really what if you recall the difference of two squares, really what it's doing is the conjugate is just allowing us to create a situation in which we're calculating the difference of two squares to remove the radical in the denominator. So in this case, I have 3 over 3 plus root 5. My conjugate simply is going to be 3 minus root 5. 3 minus root 5 over 3 minus root 5 is 1. So again, I'm just hairbrushing. Again, I have the same value, or the same hair. I'm just changing the style that it looks. So now I end up with 3 times 3 minus root 5, which is 9 minus 3 root 5, over 3 plus root 5 times 3 minus root 5, which is equal to 4. Now, how did I get 4 out of 3 plus root 5 times 3 minus root 5? So remember, again, difference of two squares, 3 plus root 5 over 3 minus root 5. And we think about the difference of two squares as a minus b times a plus b gives us a squared minus b squared, right? In this case, we just have 3 squared minus the square root of 5 squared, which is equal to 3 squared minus 5, which is equal to 9 minus 5, which is equal to 4. All right, so if you don't believe me, then we can go through the whole foiling process, and we'll rewrite this using FOIL. So 3 times 3 is 9. So first, outside, 3 times negative root 5 is minus 3 root 5. Inside, plus root 5 times 3, so plus 3 root 5. And then last, root 5 times negative root 5 is minus root 5 squared. Minus 3 root 5 plus 3 root 5 reduced to 0. Now I'm left with 9 minus root 5 squared, which is equal to 9 minus 5, which is equal to 4. All right, so you can see the similarity, or the exactness, in the relationship between the difference of two squares and what we're using and doing with the conjugate of the denominator. So we end up with 9 minus 3 root 5 over 4. Okay, last part, just some examples of conjugates. So the conjugate of a plus b is a minus b. The conjugate of a minus b is a plus b. The conjugate of a plus the square root of b is a minus the square root of b. And the conjugate of a minus the square root of b is a plus the square root of b. In a similar fashion, if I wanted to find out what the conjugate of a minus b, square root of a the square root of a minus b is, the conjugate would be simply the square root of a plus b.